What's up, guys? How are you today? So I made a Unit 1 review not long ago, but I think it was much too rushed, and so I decided to make a video for every subtopic and make a playlist instead, so you guys can find the content you need quicker. So today I'm pretty excited. It's my first one. It's gonna be I think it's gonna be complex numbers, and I think this is the hardest part you're gonna encounter in your first semester of IBAHL. And for IBAIHL, maybe you have some content overlap too. I'm not too sure, but hopefully this video will be helpful. So yeah, let's get right into it. So, whoops, got an answer there. I recorded one time and it failed, so my second try. Yeah. So what are complex numbers? So the complex number idea really revolves around this definition of I. So I is a really special thing. And what I is that it's defined as I squared is equal to -1, meaning that it's the square root of -1. And you might think like, oh, we can't square root negative numbers. Well, that's like what is like kind of like groundbreaking thing, It's a thing you've never encountered before. And we call it an imaginary number. Actually, we call I the imaginary number. So, it's a one and only, it's the most special one. And we'll see in some applications later on why it's so important. So I have these small exercise for you. So what's I to the power of 70? So you guys know a lot about powers. So we know that I to the power of 70 will be equal to what? I 68 times I squared, right? And big eraser. If we know I have 68, we know it's I have 4 to the power of 17. And I of the 4 is, square root of -1 to the 4th is going to be 1. So all of this is going to be equal to 1. And I squared is equal to -1. So the answer of I to the power of 70 is going to be -1. So I think the powers of I are really important. You're never going to really get tested independently on this, but it's a good concept to know. And the first thing and the most straightforward way that we'll be talking in a form we'll be talking about this video is Cartesian form, okay? So z for every complex number z is going to be written as a plus bi, where a is the real part and b is the imaginary part. And let's do some operations with them. So I think this is pretty basic for you guys, but it's always nice to come back and practice a little bit of math because you can never get better at math without like doing some problems, doing some easy stuff, putting in work. So if you're doing addition and subtraction, we want to put the real number and imaginary number. We want to deal with them separately. So for addition, z plus w, we're going to add the real numbers, so that's 4, and add the imaginary number, so 2i minus I, that's going to be plus I. For minus, the same thing, so real part, 1 minus 3, -2, the fake part, not fake part, imaginary part, 2 minus -1, so that's 3, plus 3i, that's the imaginary part. And when you're timing it, you just want to distribute, okay? So 1 plus 2i. Pause the video if you want to do these yourself. Is that a thing like they always say? Pretty cool. This will be equal to what? 3 plus 6i minus I. And so it'll be minus 2i squared. And always remember that I squared is going to be equal to minus 2i squared is going to be -1. So it's going to be plus 2 actually. So over here, we're going to put the real part and imaginary part together. So 3 plus 2 is equal to 5. 6i minus I is equal to 5. So plus I. And for multiplication, my camera's big. Yeah, that's better. For multiplication, sorry, for division. We want to times the denominator by its conjugate. So using what we know that a plus b times a minus b is equal to a squared plus b squared, right? Minus b squared, actually, sorry. So yeah, using this, we want to times the conjugate. You guys know what the conjugate is like for every, we'll talk about it later, actually. So for 3 minus I, the conjugate is going to be 3 plus I, and you want to times both sides by it. So we just like multiply now. So 3 minus I, because we don't want imaginary numbers in a denominator. So using this, we're going to get rid of it. So 3 minus I times 3 plus I is going to be a squared plus b squared. So 9 minus I squared. So that's going to be 9 minus -1, so 10. And the top is just, we're going to try to distribute it, and it's going to be 1 plus 7i. And yeah, so if you did yourself, here's the answers. Check if you got it right. It's the orange part down here for all 4 of the operations. Yeah, so that's basically what you need to know about Cartesian form. And how I understand the Cartesian form is through the complex plane. So this is called an arcane diagram. So it's basically a plane where it has a real axis and imaginary axis. I've drawn a pretty good label here. So these are on the top left here are all the notations you need to know for IB especially. So the real part, the imaginary part, it's gonna be A and B, real of Z, IM of Z for every complex number Z. For the conjugate, you have this asterisk. For every A plus BI, the conjugate is A minus BI. For the modulus and the argument, it's notated as, the modulus has absolute values, symbols, kind of, and the argument is like arg of Z. And basically, what you want to look for in a complex plane is that you want to plot it, for this example here, I have Z equals 3 plus 2i, so it goes 3 from the real axis and up 2 for the imaginary axis for how many I it has. And the modulus, it's going to be the distance from this plotted vector thing to the origin, and the argument is going to be the angle of it to the positive x-axis, and we'll explore more later. Use a bit of trigonometry actually. So what are the properties of the modulus? So we know that it's the distance, right, from the origin. So if you really think about it, if this is the real part, oh god, it's a horrible triangle. Okay, so if this is the real part, we know the real part was written as a in Cartesian form, and this is the fake part, so b, or like bi. We know that the distance here is going to be the square root of a squared plus b squared, right? So this is the modulus. This is the distance from it to its origin. Is a right triangle because it's plot on a graph. And here are the properties of modulus you need to know. I'm gonna talk about them. I don't think you guys need to memorize these either. It's kind of like it should be intuitive for you, but it's fun to think about. Like why would this stuff all work? Yeah, but make sure that you're very familiar with how to calculate the modulus when given a Cartesian form. All right, next the argument. So the argument is the anti-clockwise angle, and you don't think about like anti-clockwise, clockwise. Just think about it as the distance from to the positive x-axis, and please remember that it needs to be in between negative pi and pi for radians. Okay, normally it's in radians because it's much useful. Yeah, but the reason why we calculate the argument as I show you guys up here, it's gonna be the inverse tangent of b over a. That's because I over scrolled. Because we know for every b and a, the tangent is defined as tangent of theta is defined as b over a. So if we know the b of a, we know that the inverse tangent, oh god, inverse tangent of theta will be the angle you were looking for. Right, and you need to remember for every quadrant, the angle is kind of different. So I've got the adjustments here for you guys. It's not that easy to memorize because like, oh, is it bigger, is it smaller? But what I like to do is I like to plot it out on imaginary axis and then like match up with the angle, like, oh, is it in the right quadrant? I think that's a really weird thing about it. Like, yeah. All right, and why do we need to know this? Because on the first test you'll be given a unit circle, but you're not gonna have it on the second test. So I think it's good here for me to come here. Sorry, for me to like give you guys some idea of familiarizing yourself with the unit circle. Here's three complex numbers, and not without a calculator, we want to like be very familiar with like finding an argument directly. So 1 plus square root of 3, kind of want to plot out, like it's gonna be like kind of here. What angle is that? It's gonna be like the tangent inverse of square root of 3 over 1, and you can find that in radians it's gonna be this, pi over 3. So that's the argument for it. Negative 2 plus 2i, so negative 2 plus 2i here. That's the tangent inverse of negative 1, but it's in the second quadrant. You kind of can just tell by plotting it out. That's why I like it. So it's going to be, the argument's going to be 3 pi over 4. And for the last one, negative 12 pi minus 2i, that's going to be like here. And you can simplify it, or you can like just tangent it. But after you use the inverse tangent, you can find that the radian is going to be this one, 7 pi over 6. So yeah, for these like very common in angles on unit circle, like just be very familiar with them because you're gonna use it a lot and it's gonna be really useful. Right. Yeah. And that's it for today's video. I'm actually gonna make 1.13 and 1.14 later, so you guys can watch that in the playlist. Yeah, so Thank you so much for watching today. I really enjoyed making today's video, and I'll see you in the next one. And trailer for the next one is gonna be on the different forms to express the complex number. So you're gonna know why finding the margin and argument are so important. All right, see ya.